It hasn't. There. Okay, so what we're gonna do today is we're gonna add one more thing to what the balanced equation tells us. So a balanced equation not only tells us the mole ratio and the ratio of particles, but it can also tell us the ratio of volumes. So in the book, it tells you that nitrogen gas and hydrogen gas go together to make ammonia. And then when you balance that, a 2 there and a 3 there, and now it's balanced. So what we did before this is we said that this means that there's 1 mole of nitrogen for 3 moles of hydrogen for 2 moles of ammonia. And all of these have to be gases that we're comparing, or this doesn't work. So you have to look for the little g that means gas. And so what this also tells you, besides the mole ratio, is the volume ratio. So if we have 1 liter of nitrogen gas, that means we need 3 liters of hydrogen gas, and that'll produce 2 liters of ammonia gas. So the first problems are really easy. The first problem says that how many liters of ammonia gas are going to be produced if we have 5 liters of nitrogen. So if we have 5 liters of nitrogen, and they want to know how many liters of ammonia. It's honestly just as easy. If there's 1 liter of nitrogen, then there's 2 liters of ammonia. If you want to set up a proportion, you can. You can put your 5 liters of nitrogen gas, stick that over 1, and then you're trying to get ammonia, so you put liters of ammonia on the top and liters of nitrogen on the bottom, and there's 2 of these for every 1 of these, so there's 10 liters. Or you can kind of do a common sense too. So if it's a 1-to-2 ratio, if there's 5 liters, there's 10 of the ammonia. If there's 6 liters of nitrogen, then there's 12 liters of ammonia. It's just a 1-to-2 ratio. So that's the one new thing. And then the other new thing is taking this information and putting it with yesterday's information. Yesterday's information was an equation that you have to use if you don't have beginning and ending conditions. So we use Charles' law and Boyle's law and Gay-Lussac's law and the combined gas law, and they would say, this is the initial volume and this is the final volume, and this is the initial pressure and this is the final pressure. Well, what happens if you don't know those things? If you don't know those things, then you're going to have to use what's called the ideal gas law. So the ideal gas law is the pressure times the volume equals the number of moles times the constant that we wrote down yesterday on our equation sheet times the temperature in Kelvin. So now we can use this with the mole ratios and figure stuff out. So in the book, on page 462, it says ammonia is synthesized from hydrogen and nitrogen. 5 moles of nitrogen reacts completely with hydrogen at a pressure of 3 atmospheres. I'm gonna write that down. The pressure is 3 atmospheres. And a temperature of 298 Kelvin. So that was nice. I'm gonna have to change it from Celsius. They want to know how much ammonia in grams is produced. They want to know how much of this in grams is produced if we have 5 liters of this. In the last chapter, we were given grams and we changed to grams. There's nothing that will allow you to change from liters to grams. But we can go from liters to liters and then use what we learned yesterday to get moles, and then we can change from moles to grams. So it's a 3-step process. We know we have 5 liters of nitrogen gas. If we have 5 liters of nitrogen gas, the very first step is to use the liters and change to the ammonia. So 2 liters of ammonia for every 1 liter of nitrogen. This is what we just did. That means I have 10 liters of ammonia. And then I look at my chart that I'm allowed to put on my equation sheet. Liters is a volume. Liters is a volume. So this is a volume. So now I have a volume, I have a pressure, and I have a temperature. And so I can use the equation from yesterday. PV equals nRT. I know the pressure. I know I just figured out the volume. They gave me the temperature. The constant is a constant. I can figure out the number of moles. If I figure out the number of moles, then I can change the grams. First step, liter comparison using the balanced equation. Second step, inert gas law. Ideal gas law. PV over RT equals N. I just rearrange it because this means multiply. So I rearrange it and solve it for the number of moles. I take the product of P and V and divide it by the product of the constant and the temperature. So this is going to be 3 atmospheres times the 10 liters I just figured out, divided by the product of that ugly, that's the constant. You just have to know that you have to use that. Multiplied by the temperature, 298. Kelvin will cancel out. So I take 30, 3 times 10, and I divide it by the product of 0.0821 and 298. And I get 1.23 moles. The atmospheres cancel out, and the Kelvin cancel out, and the liters cancel out, and I'm left with a mole. N is the number of moles. And if they would have asked for that, I'd stop. And some of them, this is like the hardest one. Some of the ones that you're gonna do on your own, they just ask you for moles. But this one actually wanted to know the mass, so that's why it's 3 steps. The liter comparison, the liter ratio, using the ideal gas law, and then I'm gonna take the 1.23 moles of ammonia, and I'm going to change it to grams of ammonia. Grams will go on the top, moles goes in the bottom. 1 mole of a substance is equal to the formula mass, which you get off of the periodic chart. So you take 1 nitrogen, 14.001, plus 3 hydrogen, you get 17.028. You multiply that by 1.23, you get 21 grams of ammonia. And that's the answer. This is the hardest one. This is absolutely the hardest one. You have any questions?
No.
Let's do one from yesterday. Just this one of the easier ones. Yesterday, let's see. Yesterday on page 455, let's find a good one. Let's do 28. 28 says, what's the pressure in atmospheres? What's the pressure in atmospheres of a 0.108 mole sample of helium gas at a temperature of 20 degrees Celsius if the volume is 0.505 liters? So you know that this is an ideal gas equation because they only give you one of everything. They only give you one of everything. So what you need to do is pick out the information and label it. So they want to know what the pressure is, so that's P. This is, I think this was number 28. They want to know what the pressure is in atmospheres, and it says that they have a 0.108 mole sample. So you've got to know that moles goes with N. The moles goes with N. So N is equal to 0.108 moles. And then it says, what's the pressure in atmospheres of a 0.108 mole sample of helium? Helium's not important for these. It could be any gas. At a temperature of 20 degrees Celsius, okay? Well, just like the other problems, can't leave these in Celsius, you've gotta change them to Kelvin. And the volume is 0.505. And that's in liters. And so you're gonna use the equation PV equals nRT. They never give you R in the problem. You have to have it written on your equation sheet so you can use it. The previous problem when I did this, I was looking for N. Now I'm looking for P. So that means I'm gonna divide both sides by the volume. And the pressure is gonna be equal to nRT over V. So this is gonna be 0.108 moles times 0.0821 liter atmosphere per K-mole times 293 Kelvin. You can see why we had to change that to Kelvin so it would cancel out in the constant. And then I'm dividing it by the volume, 0.505 liters. So the moles cancel out, and the Kelvin cancel out, and the liters cancel out. And I'm left with atmospheres, which is what pressure should be measured in. So I take 0.108, multiply by 0.0821, multiply by 293, divide by 0.505. And I get 5.14 atmospheres. So that's what we did yesterday. That's one of the ones that you're supposed to do for homework. That's everything. That's the whole chapter. So what I plan on doing on Monday is mixing them up. I'm gonna put on the overhead one problem at a time, and we'll get them all set up together, and then but I'll have them all mixed up. And you can see which ones you need more practice on, and then we'll do that on Tuesday, and then Wednesday will be your test. You have any questions?